Namaste students, welcome to Rhchemistry. So in today's Jee Main bits from Nta Abhyas part, hydrocarbon chapter I am going to discuss. So if you are aiming at NEET also, remember, you can see my previous NEET boosters also. And if you are JEE student, you can see this and that. If you are NEET student, you can see that and this both. So in all these cases, you are going to learn some important concepts behind the questions. So here I am not assuring you that you will score very good marks if you follow only these. But definitely if you follow these, if you understand these, it will boost your confidence and it will boost your concepts, remember. So it will help you to score good marks in upcoming JEE and NEET exams. Yes, first question you will say, in the reaction compound, compound C is, remember, right? So from this chapter we have to consider. So here, now you can see, first step is Grignard reagent formation. Now you can see we have two Cl and Br, two halogens. So in both the case, Grignard reagent may be possible. But only one case the product is formed in the major product. What is that? See, one equivalent is there. If it is two equivalent, you could have react here also. But out of these two, which bond will undergo cleavage easily, that will form Grignard reagent to the greater extent. Now you can see Cl is large, smaller, Br is larger. Hence remember, Br is good leaving group. Hence because of this reason, I will write it here. The A is, remember, like this. C will be as it is, Cl will be as it is. And here you are going to get MgBr. See, it is not the thing that Grignard reagent is only bromide. It is not like that. So RMgX is the formula. X may be Cl or Br. But I will break here CBr bond because this is weaker than this. So after this, D2O. Remember, when I react with D2O, it is just like water. D2O, I will write as DOD. So D is acidic, remember, it is acidic one. Just like water, it is acidic one. So whenever acidic hydrogen containing compound react with this MgBr is replaced with hydrogen. Correct? Here instead of hydrogen, we will write D. So our product becomes, remember, like this. Cl will be as it is. And here you are going to get D. You are going to get D like this. Right? Now this will undergo Grignard reagent. So this will undergo Woods reaction. This is Woods reaction, Na dry ether. Now D cannot form, but this Cl is there, correct? This is Cl and the same molecule another. The same molecule another. I will write it here. So this is Cl, this is Cl. This is Cl, this is Cl is from NaCl, and this bond formation take place. So this and this bond formation take place. So second position D, the answer is in which case? So B should be the answer here. See, B should be the answer. You can cross check with. So this Cl when it removed and it formed the bond, this alkane is going to form this Cl. See, 1, 2, second position D, second position D, second position D. So hence the answer for this question is B. Now, highest heat of hydrogenation is shown by which of the following compound? Important type of concept, remember. Here I will tell you what is heat of hydrogenation. Generally you have not discussed in case of the NEET or CET part. Heat of hydrogenation is nothing but delta H of hydrogenation, we call it as hydrogen. It is not hydration, hydrogenation. So it is nothing but, remember, in this particular case, this is defined as heat released when an alkene undergo catalytic hydrogenation. Catalytic hydrogenation. So, for example, when CH2 double bond CH2, when catalytic hydrogenation take place in presence of nickel, this will form CH3 single bond CH3. Correct? So the heat released in this particular case, delta H hydrogenation, we call it as around minus 32 kilojoules, like that. It is always negative because it is released, remember. So now, How it is related to stability we have to see. Because in out of these which is more stable, you will get the answer. So how it is related to stability? So always remember delta H of hydrogenation inversely proportional to stability. Inversely proportional to stability. Why it is inversely proportional to stability? I will tell you. See, if this is less stable, if it is less stable, remember, it will undergo hydrogenation very easily. Hence, heat released will be more. Whenever this is more stable, alkene is more stable, it will not undergo hydrogenation so easily. Hence, remember, that will release less amount of energy. Hence, you can say delta H of hydrogenation and this stability is inversely related. Remember that. Now you can see highest heat of hydrogenation we require. Highest heat of hydrogenation means, remember, lowest stability. That you have to see. Which one is lowest stable? See. Always in case of the alkene, stability depending on conjugation. Whenever there is a conjugation, stability will be more. Hence you can say definitely this is having conjugation, stability is more, hence less heat of hydration. This is not the answer. Here also you can say conjugation. So this is conjugation with this and this is conjugation with this. This is also not the answer. This is conjugation, and this is not in conjugation, but these two are in conjugation. Hence remember this is also not the answer. But here you can see no double bonds are in conjugation. Hence answer should be A. Because lesser the stability, more is the hydrogenation. So lesser the stability because there is no conjugation, there is no resonance. Hence more is the heat of hydrogenation. So heat of hydrogenation concept, whenever you will come across, think about this. Hydrogenation, so stability inversely related. Remember that point. Then third one. Which is the most suitable reagent among the following is to distinguish the compound 3. This one. 3. From the rest of the compound. See, Br2 in CCl4, OSO4, cold, aqueous, alkaline KMnO4, ammonical AgNO3 solution. Now you can see one thing. This is having triple bond. This is also triple bond. This is double bond, right? So Br2 in CCl4 you will add. We know that Br2 will form addition reaction for double bond and triple bond. So it can add to here also, here also, here also. But Br2 in CCl4 can distinguish 2 from the rest. But we need 3 from the rest. Hence it is not the answer. Then we know that OSO4 will react with both double bond and triple bond. Osmium tetroxide is the oxidizing agent. So I have made separate video on oxidizing agents in organic chemistry. So please see that under this tips and tricks series, it is there. Tips and tricks series. Fine. OSO4, it will react with both double bond and triple bond. So you cannot. Cold aqueous alkaline KMnO4 react with both double bond and triple bond. It cannot. But ammonical AgNO3 solution, whatever you can see here, this will react with only acidic hydrogen. Remember, this will react with only acidic hydrogen. In which case acidic hydrogen is present, definitely terminal alkynes are acidic in nature. So this hydrogen is, remember, acidic hydrogen. So hence answer for this particular question is D. D is the answer. So it will differentiate compound 3 from the remaining. Then numerical, integer type. How many of the following compound will form acetic acid on reaction with acidic KMnO4? So we know that acidic KMnO4, so acetic acid should be formed. So one by one we will see. Propene is there. I will write only skeletal structure. So CH3, CH, I will write complete structure. CH, CH2. Remember, KMnO4 means how the bond cleavage take place. This bond will cleave here, one bond here, one oxygen here. So you are going to get, remember, CH3 or CHO. Here in this case, KMnO4 is there. So 2 oxygen here, 2 oxygen. So COOH, bond cleavage take place like this. And 2 oxygen is here, 2 oxygen is here. So plus CO2 plus H2O. Why I have written CO2 plus H2O? Because HCOOH. That is, remember, formic acid, always it will undergo further KMNO4 to form CO2 and H2O. This is forming. This is correct. 2-methyl-bute-2-ene will take. See, bute it is, 2-methyl it is, bute-2-ene they are asking, so double bond is here. When I cleave this, remember, 2 carbon wherever you will get, that is acetic acid you are going to form. Remember, 2 carbon wherever you will get, acetic acid you are going to get. So here this is an acetic acid. This is give rise to ketone, remember. So definitely this will give rise to ketone. Acetone you are going to get. Right? So in this particular case, CH3COH, 2-methyl-bute-2-ene is also going to give rise to CH3COOH plus CH3C double bond of CH3. So this is also possible. Then 2-methyl-propene will take. So 2-methyl-propene if I take, see, 2-methyl-propene it is, double bond. Right? Now cleavage is here. Cleavage is here means C it is there, means in between you are, it's the same thing, same product you are going to get. That is CH3 C double bond O CH3 plus CO2 plus H2O. Remember, in this particular case also you are going to get this one, not acetic acid. Hence this is not the answer. 2-methyl-propene only, and I have underlined which is possible. Then bute-2-ene will take. Bute-2-ene if I take, so C double bond C. See, here it is not possible. H3 I will write. This cleavage like this, right? So definitely it is 2 carbon atom compound, means you will get CH3COOH only. 2 molecules you are going to get. So how many molecules they are not asking. Which of the molecule will form acetic acid they are asking. So cyclohexane. Definitely cyclohexane, what happens is, see, cyclohexane, when cleavage take place here to form. So adipic acid you are going to get it here. Remember, adipic acid, COOH, CH2 4 times COOH. COOH, this is the long chain. COOH, COOH. Adipic acid we will call it as adipic acid it is. Which means this one will not give, this one will not give. So remaining 3 will give. So bute-2-ene will give. Remaining 3 will give means answer for this question is, remember, answer for this question is 3. So 3 is the answer, numerical integer type of question. Then this is also numerical type, very interesting one, very important. This type of question you can expect. See, in this molecule, X is number of primary carbon atom, Y is number of secondary, Z is number of tertiary, M is number of quaternary carbon atom. So what you have to do, what is the value of X they are asking? What is the value of X plus Y plus Z plus M divided by 2 they are asking? See, primary means, remember, I will write primary iddali 1 ant baritini 1, I will write secondary 2, tertiary 3, quaternary 4. So this is primary 1, this is primary, this is primary, 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 primary. So primary how many is there? 1, 2, 3, 4, 5, 6, 7. 7 primary. Correct? Now secondary will say. Secondary means 1 carbon surrounded by 2 more carbon. So this is secondary, this is secondary. Correct? So now this is secondary, now this is secondary, this is secondary. So total how many secondary? 5. Then Z is tertiary. Tertiary means 1 carbon surrounded by 3 more carbon. So this is tertiary, this is tertiary. Which means, and this one is tertiary. 3 is there, 3 are there. So 3 plus quaternary is only 1. Quaternary is only 1. Divided by 2. So total 7 plus 3, 10 plus 6, 16 plus divided by 2 is 8 is the answer. So answer for this question is, remember, 8. Answer for this question is 8. Now here is very important. This concept you have to learn. Why the product is going to be different. See, CH3 C double bond to CH double bond CH CH3 HBr, find the major product. It looks to be very simple. HBr is there, correct? HBr is there means attach one hydrogen to one Br, one hydrogen to one carbon double bond, one Br to one carbon double bond. Here you can see both are symmetrical. So one hydrogen is there. You will think that any one type, if you add Br, you will get the product. Wrong. See here, both the products are given. See, this product is also given. This carbon Br they have attached, right? This product is also given, Br it is attached. Then which is the correct one? That is very important here. Which is the major product? Which is the major, to both the product you are going to get, but which is the major product out of A and B? This is not possible. This is not possible. So these two are not possible. You can easily tell. Out of these two, which one? See, I will tell you. See, whenever you will get CS3 C double bond O, CS double bond CH, CH3 plus HBr. Once you remember the mechanism of this, so first what happens is H plus will attacks on the carbon, doubly bonded carbon, so that carbocation is going to produce. Which type of carbocation? Two types of possible. So I will write two types, CS3 C double bond O, carbocation on this carbon, CH, single bond CH2, CH3, and CS3 C double bond O, then CH2, CH, carbocation here, then CH3. See, carbocation formation on the first carbon adjacent to the C double bond O, second carbon adjacent to the C double bond also I have made. But out of these two, which is more stable, that is very, very important here. Out of these two, which is more stable. Remember, stability of the carbocation depending on the plus psi effect. Right? So tertiary is more stable than secondary, more stable than primary, because in tertiary there is a plus psi effect from the alkyl group. But one thing you remember, this group is, remember, producing minus I effect. Go back to inductive effect and see that. So COOH, CO, CN, NO2, these will produce minus psi effect. So minus psi effect. Minus psi effect means definitely this is not stable. This carbocation is not stable. This carbocation is more stable because it is surrounded by two alkyl group. It is surrounded by one side alkyl but one side minus psi effect. So hence remember, this is not stable. This is stable. When this is stable, you are going to get the product. Next step is what? Br minus attached to this. So second carbon from this side, second carbon Br. So this should be the answer. A should be the answer in this case. See, this when I form, you are going to get this only. Br minus is going to attack on the this carbocation forming the product, this one. So answer is E. The seventh one. This is also another important type of question. You have to learn so many things here. So see, when it reacts with first step dilute H2SO4, then heating, major product formed. So in this particular case, what I will do is, I will show you step by step how it is. See, first step I will write. Double bond is there, single bond is there. Dilute H2SO4 means, remember, it is hydration. Hydration means first what we will do? H plus. H plus we will do. Then OH minus attack. So in this particular case, when H plus is added, so remember, carbocation is going to form. How H plus is going to add? I will tell you. In this particular case, H plus will add to this carbon. Remember, H plus will add to this particular carbon. Here on this carbon, so that carbocation is formed here. See, like this. Carbocation is formed here. So I will write like this. Correct? So carbocation is formed at this carbon, bridge carbon. Now what happens? This step is very important. Now what happens is, remember, ring expansion. Ring expansion, that is very important. When you have to do ring expansion, like this, whenever you will see, now what happens is this carbon will form bond with this carbon. Right? So this positive charge will shift to this carbon, this 5-membered becomes 6-membered. That is called as ring expansion. So like this, you can see, like this. I will write like this. So 6 bonded. So you are going to get ring expansion, I will tell you. So like this, and this will be as it is here. See the difference? Here, whatever the bridge carbon you are seeing, this will form bond with this, so that this one bond, 1, 2, 3, 4, 5, 6. So 6-membered ring is going to form. But now that positive charge will shift at this carbon. So ring expansion, clearly see that this is very important type in the JEE and NEET exams. Remember, ring expansion take place. But remember, this ring expansion, it is secondary. This is quaternary carbon. This is secondary. So hence it is not stable. Hence remember, immediately what happened? Methyl shift take place. Methyl shift take place. Methyl shift take place. Methyl shift take place means this methyl group shift will shift here. The carbocation will shift here to make a tertiary. So like this. So here one positive charge and here methyl group is going to form. So then remember next step is OH minus attack. OH minus attack. OH minus attack on this carbocation, very simple. See, OH attack here. Right? Now remember they are telling heating. See, they are telling after stereoisomer heating. Now we'll heat this. When you heat this, remember OH from here and H from here you are going to remove. So you are going to get the product as like this. Here one, double bond here. See, this product is going to form. This product is similar to what? This product. Correct? See, both the product you can see. This product is similar to A. Hence the answer for this question is A. See, ring expansion type, very, very important. Remember that. Then, how many dichloro products, including stereoisomers are possible when 2-chloropentane reacts with Cl2 in presence of UV radiation? 2-chloropentane structure we'll write first. 2-chloropentane means remember CH3, C, Cl, H, CS2, CS2, CS3. 2-chloropentane. Remember, the product depending on type of hydrogen atom. Always remember chlorination product depending on type of hydrogen atoms. First we will see the product, then we will see that. See how many types of hydrogen atoms are there, that I will tell you. See, this is one type of hydrogen. This is one type of hydrogen. Right? So I will tell you this. This is one type. First type. Remember, this is the second type of hydrogen. Second type of hydrogen because atmosphere around it, this is different, this is different. Remember, this is third type of hydrogen. Third type of hydrogen. So replacing this H with Cl, this H with Cl, this H with Cl. How many product you are going to get? Total 3 product you are going to get. Remember, in out of these 3, no one will form stereoisomer because no one is chiral carbon. No one is having chiral carbon. Next you see, this is fourth type and this is fifth type of carbon. Now when you replace fourth type, see, I hope you understood first, second, 3. When I replace Cl, 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 you will get one product. So there is no stereoisomer product. But now I will replace this one. Fourth carbon if I replace, see what I am going to get? CH3, CClH, then CH, Cl, CS2, CS3. Fourth carbon, one hydrogen replaced by Cl. Now you can see this is also one stereoisomer. Chiral carbon. This is chiral carbon means you are going to get D form, L form, which means this will result in 2 products. Remember, one is this and another is dextro of this or levo of this, mirror images of this one. So you are going to get 2 here. Right? Now, fifth carbon if I replace, what happens? See, fifth carbon when I replace ClH, CH2, CHCl, CS3. See, this is also chiral carbon. Star I hope I will put. Chiral carbon wherever is there, you will end up with 2. Right? Through 2. Now total you see. See, only these are the possibility. First, second, third you will replace 3 product. Fourth carbon you will replace. It will form a stereoisomer because of chiral carbon 2 product. I have written first it one and this is a major mirror image of this one another. So here also second, here also fourth, fifth one. This when you replace stereoisomer because chiral carbon. So 3 plus 2 plus 2. Answer is 7. See, this you have to leave because they are not given the condition like that. So this you have to leave. So leaving this, total 7 product you are going to get. So the answer for this particular question is, remember, 7. So like this you have to solve. Then 9th one. Which of the following is a major product when 3-phenylpropene react with HBr? Put this Markovnikov's rule. 3-phenylpropene. 3-phenylpropene means how it is? See, I will draw it like this. So 3-phenylpropene. CH2, CH double bond, CH2. 1, 2, 3, 3-phenylpropene. Now when it reacts with HBr, once again you are going to get first step carbocation. So carbocation I will write it here. Carbocation CS2, C plus, right, H, CS3. Secondary carbocation. Now directly what we will do? We will add Br to this carbon. So we will tell that the sir answer is A. Correct? Answer is A. But wrong. Very important, wrong. Because this is not that much stable. Now there is a one opportunity for this carbocation to become more stable. Hence what it will do? Hydride shift take place. Hydride shift take place. Hydride shift from where? This hydrogen will shift here. Positive charge will shift here. I will show you how it is. See. Now positive charge comes on this carbon. It become H and single bond CS2, single bond CH3. See, the carbon which was present, positive charge here, that positive charge shift here, this carbon, and here you can see CS2, CH3. Why this take place? To become more stability. So remember, wherever this type of, see, here also, shift ring expansion, then methyl shift take place. Why? Because to become more stable. Wherever the stability is more, major product formation depending on the stable carbocation. So now you add Br to this. So Br minus, when I add, you are going to get the product as, so CHBr here, CS2, CS3. So the product formed is this one. So this product, where it is there? So this B is the answer. B is the answer. So like this, remember, you have to think about. Last one. In the following sequence of the reaction, maximum number of atoms present in molecule carbon, sorry, C, it is C, molecule C in sp3 hybridization. What they have given? A give rise to red hot copper tube, B, CS3Cl, AlCl3, C. A is the lowest molecular weight of alkyne. Lowest molecular weight of alkyne means what? CH triple bond CH. This is a possibility. When it passed through red hot copper tube, see, copper tube or iron tube, whatever the tube they will give, but red hot is very important. Wherever red hot is there, that should be given rise to benzene. Remember that, benzene, very important. This, when it reacts with the CH3Cl and AlCl3, it is there. CH3Cl and AlCl3, which means this is Friedel-Crafts alkylation. See, don't think that, sir, anhydrous is not given, then how it take place. See, those small things they will not mention in the reaction. That you have to remember. So AlCl3, CH3Cl is given. So you are going to get methyl benzene, that is CH3. Now they are asking, in this product C, this is product C, how many carbon atoms are there in sp3 hybridization? See, sp3 hybridization, see, all these benzene rings are sp2, correct? This is the only carbon having sp3 hybridization. Hence the answer for this question is 1. Answer for this question is 1, remember that. So this is about the hydrocarbon JEE 10 question I have solved. Almost 30 minutes I have taken to solve 10 question. So you have to finish it in 20 minutes actually. One question, 2 minutes. But here I have to convey the message to you in the proper manner. So I have taken more time. So, but you can solve this in within 2 minutes of time. Yes, thank you for watching. So share and like and comment if you have any doubts. So subscribe to the channel if you have visited for the first time. Thank you. Have a nice day.